Good morning. I hope all of you continue to remain healthy. And as I've said so often, I'm so looking forward to when we can be back together in the classroom. So today we're finishing our final set of guided notes for systems of equations. And our last method that we're going to focus on is the elimination method. So far you know how to solve a system by graphing. And you've also learned how to solve a system by substitution. So this last system of elimination comes with several steps here. I'll read these again. They usually don't make a whole lot of sense till we start applying them into the problems that we're doing. Step 1 says you must have the same or opposite coefficients for one of the terms in the system of equation. It may require you to multiply one of the equations by a factor that will give you the same or opposite coefficients. Remember, coefficients are the numbers in front of the variable. Opposite means one's positive and one's negative. Step 2 says you will add or subtract the equations to eliminate one variable, and that depends on if your coefficients are opposite or the same. Step 3 says solve the resulting equation for that variable. So then you'll have an answer for that variable and you'll substitute it back into that original equation or either equation, it really doesn't matter, to find the value of the first variable. Remember, anytime you get your solution to a system of equation, it does not matter what method you're using, you can plug that coordinate back in and check that your answer is correct. So obviously any homework that you're doing, once you get an answer, you should be able to plug it in. If you don't get that it is true, then you've done something wrong and you should try it again. Okay, so let's do some practice and we'll start learning this method. The first system is 5x minus y equals 12. And 3x plus y equals 4. So I'm focusing on my variables. I look at my x and I look at the coefficients in front. In my first equation I have a 5, my second I have a 3. They are not the same coefficient. They are the same sign though, they're both positive. So let's look at our y. On our y variables in the first equation I have a -1. And in the second equation, I have a positive 1. So that's a great thing. We're going to eliminate this. How do I eliminate when I have a -1 and a positive 1? I add them together. When I'm adding those together, I'm adding everything, the x term, the y, and the constant term. So 5 plus 3 is 8x. -1y plus positive 1y is gone. It's eliminated. That's what we're trying to do. Get this to solve in terms of one variable. And 12 plus 4 is 16. To get x by itself, I divide by 8 and x equals 2. Now I have part of my solution. You can take and put this into either equation. I'm choosing the second one. It's fine to choose the first one. So I get 3. Instead of x, it's times 2 plus y equals 4. 6 plus y equals 4. I'm going to subtract 6, and I'm going to get y equals -2. That means my solution to this system is x is 2, x comes before y, and y is -2. That's my answer. Okay, let's try another one. 6s, it's not an s, it's a c. 6c plus 7d equals -15. 6c minus 2d equals 12. Okay. So I'm going to start. I look at my coefficient in front of C. They are both 6s. They are the same sign. They're both positive. I still look at my D's just in case I want to see what's going on there, but I don't have the same coefficient, but I do have opposite signs. So obviously I'm going to eliminate my C's. How do I do that? Well, if I add 6 plus 6, that's not going to eliminate them. So I'm going to be subtracting. I'm going to show subtraction. This subtraction will go to every term. The 6C's, the 7D, the -15. You know, we're applying it to everything. So 6 minus 6, that is 0. I eliminated C. Now I have 7 minus 7 minus negative 2. 7 minus a negative 2 becomes 7 plus 2, and that is 9D. Take a minute to think about that if you need to. 7 minus a negative 2. Two negatives make a positive. Then I'm going to my constants. Negative 15 minus 12 is negative 27. Okay, this is where the most errors occur, especially if you're subtracting your systems, because sometimes students forget to apply that subtraction to all the terms. Okay, so now that I have 9D equals negative 27, I'm going to divide by 9, and D is going to equal negative 3. I take that negative 3, and I'm going to go ahead and I think I'll put it into the first one. Again, you can choose either one. It doesn't really matter. 6 times C plus 7 times negative 3 equals negative 15. 6C minus 21 equals negative 15. I add 21 because I want to solve for C. 6C equals negative 15 plus 21 is 6. And that means C is going to equal 1. C comes before D, so my solution to this system is 1, negative 3. Again, you can plug that in and check it out. If I plug it into the first one, I get 6 times 1 is 6, plus 7 times negative 3 is negative 21, and 6 plus negative 21 is 15. Okay, let's go to the third one. Negative 3n plus 9m equals 6. Positive 3n plus 4m equals 7. I'm looking at my first variable, my n, and I notice I have the same coefficient and opposite signs. That's great. So to get that to eliminate, I'm going to add negative 3 plus 3. That's gone. I eliminated n. 9 plus 4 is 13m equals 6 plus 7. That's 13. I divide by 13, and m equals 1. Again, I can put that into either equation and solve. It really doesn't matter. I'm going to go for the second one. When I do that, I get 3n plus 4 times 1 equals 7, or 3n plus 4 equals 7. Subtract 4. 3n equals 3. Divide by 3. n equals 1. My solution is m comes before n, so 1, 1. Okay. Let's go to number 4, which is going to be a little more to it because this time we're going to have to multiply one or both of the linear equations by something to get them the same. I'll show you what I'm talking about. 4x minus 5y equals 23. 3x plus 10y equals 31. Okay. I'm looking at my x's. I have a 4 for a coefficient in the first one, a 3 for a coefficient in the second one. Those are not the same, and I have the same signs, okay? So I'm going to look at my y coefficients. I have a negative 5 in the first equation and a positive 10 in the second. Not the same coefficient, opposite signs. I tend to go for the ones with opposite signs because then I can add the two linear equations together and I don't have to worry about distributing that subtraction. But you feel free to do whatever one you want. So I'm looking at my two equations, specifically my y's. I see I have a negative 5 and then a 10. So I'm trying to find the first multiple that makes both of those coefficients the same. And if I look at 5, I know if I multiply the whole linear equation by 2, that's going to give me negative 10, which will then give me the same coefficient. Okay, so I'm going to take and come down here and I'm going to rewrite that new equation. That 2 is multiplied to every term. 2 times 4x is 8x. 2 times negative 5x is negative 10y, or 2 times negative 5y is negative 10y, and 2 times 23 is 46. Okay, I look at my y's. Same coefficient, opposite signs. I'm adding 3 plus 8, 11x. 10 plus negative 10, 0, eliminated. 31 plus 46 equals 77. I'm going to divide by 11, and x goes in, or 11 goes into 77 7 times. I take, and I'm going to substitute it into one of them, just choosing the second one. Again, choose whichever one you want. So this becomes 3 times 7 plus 10y equals 31, or 21 plus 10y equals 31. I'm going to subtract 21. 10y equals 10. Y equals 1. Now I have my x and I have my y. So it's 7, 1. And you can always test that by plugging them in. Okay, let's see what we got here. All right, I'm going to go down, and I want to do 2 more with you, and then I'm going to have you try to. Let's see where we are on time. We're at 11 minutes, and remember I have to stop every 15 minutes or else it will just cut us off. So let's see where we get to here. Let's go to number 5. 3a plus 4b equals 2. 5a plus 9b equals 1. Okay, I'm looking at my a's. They are not the same coefficient in front. They are the same sign. I'm looking at my b's, not the same coefficient. They are the same sign. So you have choices. You can either try to eliminate your a or your b. I'm going to choose my a's. I'm going to take and multiply one of them by a negative whatever that factor is so that I get opposite signs. You can leave them both the same sign, but you do have to remember to subtract if you do that. So if I look at my a's, 3 and 5, the first multiple that they both have is 15. So what times 3 gives me 15? 5. I'm going to multiply this one by 5, the top equation. Then I'm going to take the second equation, what times 5 gives me negative 15, because remember I want opposite signs. That's going to be a negative 3. Okay, now it's time to rewrite these after I have shared the factor to each. So 5 times 3a is 15a, 5 times 4b is 20b, and 2 times 5 is 10. Now, negative 3 times 5 is negative 15a. Negative 3 times 9b is negative 27b. And negative 3 times 1 is negative 3. Okay, I'm going to add these now because I have opposite signs for a and the same coefficient. Those eliminate. 20 plus negative 27 is negative 7b. 10 plus negative 3 is 7b. When I divide by negative 7, I get that b equals negative 1. I take that b equals negative 1. Okay, this time I'll plug it into the top. When I plug it into the top, I get 3a plus 4 times negative 1 equals 2. 3a minus 4 equals 2. I'm going to add 4, and I'm going to get 3a equals 6. I divide by 3, and a equals 2. What is my solution? A comes before b, so it's 2, negative 1. Okay, let's see. It looks like I have one more here to do together. Hopefully we will have enough time to do that. 5x over 5 plus y equals 7. X plus y over 4 equals 7/2. So I noticed that in the first equation, I have a fraction. And let me check, and let me fix that, because that's not 5x over 5. I'm sorry, I think my contacts are not working well today. That's a 3. So you should have 5x over 3 plus y equals 7, and x plus y over 4 equals 7/2. I want to eliminate the fraction. How do I do that? By multiplying every term by that denominator, which is 3. Okay? When I multiply the 3 to the 5/3 x, the 3's are going to cancel. I'm going to end up with 5x. When I multiply the 3 to the y, I get 3y, and 3 times 7 is 21. That's my new equation. Okay. The second one, the y has a denominator of 4, and the constant, what it equals, 7/2, has a denominator 2. So it looks like the LCD is 4 for this. I'm going to share it to the x. I get 4x. I'm going to share it to the y, and that gives me just 1y.